All right, yeah, now I get to follow that up. So I'm going to be talking about a project that we had looking at earthquake resiliency in the Portland area. This project really got off the ground, and the scope, the impact of it was truly amplified through the partnerships that we had within the project. The project itself, microbially induced desaturation for liquefaction mitigation, started out as a 2019 National Science Foundation RAPID grant. We had collaborators from the NSF Center for Bio-Inspired and Biomediated Geotechnics at Arizona State University and the NSF NERI Large Mobile Shakers at University of Texas. But then also folks came on board from local and state agencies and also industry as well. And so what I have been thinking about with this project and this talk, now that we're almost 6 years removed from the project, is just what were the conditions that made it so that folks were so willing to come on board and help this project? And then also just talking about the impact that they had to the project itself. So one of the reasons that folks were so willing to come on board, I think, is just the coolness factor of the large mobile shakers, the shaker trucks. This is T-Rex. When we went out to make the ask to people to contribute to the project, I think they said yes so eagerly because they got to work and see the large mobile shakers. And so it was great to have a piece of paper and a scope of project with the shaker trucks right at the top of it. The other is the setting of Portland and just what the challenges and the engineering hazards that we face in Portland, largely due to the seismic setting. Portland is a beautiful city. You can see Mount Hood volcano and the Cascade Mountains in the background, the Willamette River that runs through it. And then behind the picture, to the west, there's the coast and the Cascadia subduction zone. And the subduction zone, based on the geologic record, produces magnitude 8 or 9 earthquakes about every 200 to 300 years. And if you look at that rhythm of the earthquakes, you can see that based on the geologic record, they've occurred, and now we're over 300 years removed from that last large earthquake. So we are expecting a large damaging earthquake in the Portland area and the Pacific Northwest. The geologists, scientists, and engineers that have developed this knowledge over about the last 40 years have brought it to the forefront, but it's really been the work of the scientists, engineers, and advocates that have worked with outreach and media that have brought it to the forefront of the public. An example of this is the New Yorker article, the really big one that came out in 2015. This was a comprehensive description of the damage that was likely to occur throughout the Pacific Northwest. And I think that this really got the public aware of just what the imposing hazard is within Portland. One of the notes from this article is that until 1974, the state of Oregon had no seismic code, and few places in the Pacific Northwest had one appropriate to a magnitude 9 earthquake until 1994. So there was a large realization that we are largely unprepared for a large earthquake in the Portland area. Appropriately, a few months later, Oregon Public Broadcasting released a documentary called Unprepared. This focused on the state of Oregon as is in the face of a large earthquake. And we had many of our state's leading engineers, scientists, and emergency planners talk about the state of infrastructure, lifelines, hospitals, schools in Oregon, the likely damage to occur from them, and just how long it would take to recover. And I'll say that these kind of pieces of media and those that contributed to them, I think, have gone a long ways to just developing a culture in Portland of what are you doing to prepare for the earthquake? These are conversations I often have outside of work, with friends, with family. And so there is this feeling in Oregon that we do need to do something from both the public and the engineering side of things. One of the focal points in Portland is the Critical Energy Infrastructure Hub, the CEI Hub. This is about a 7-mile stretch along the Willamette River within Portland, where over 90% of Oregon's fuel is stored in these above-ground storage tanks. These tanks, the average age of them is in the 1950s, and the oldest ones date back to pre-World War II. So these are not seismically ready structures. There is, of course, the concern that, these tanks, they are on recent or young river-deposited soils and dredge-fill soils, those that are susceptible to liquefaction. Yume Wang, in the documentary Unprepared, She states, "Is there any worse place in Portland that we could have built these structures?" There is, of course, you can see that concern that in a large earthquake shaking, damage to the tanks and ground failure will lead to spills, fires, impacts to the rivers, and then also the communities that live around these tanks. So there is this urgency, this is a very, thanks to these media, to these advocacy efforts, there's a large awareness that we need to do something. We need to find solutions for areas, including the CEI hub. And so that's where this project came about, is can we test out a potential ground improvement method for treating the soils beneath the tanks and to mitigate liquefaction beneath the tanks? There's challenges to the soils in this area that conventional ground improvement methods are either infeasible or too disruptive to the overlying tanks. And so that's where microbially induced desaturation came about, in that this method could be applied with relatively little disruption to the overlying tanks by introducing a treatment solution into the subsurface, allowing it to migrate through the targeted soils. That treatment solution stimulates microbes that are already in the soils to produce nitrogen gas, and that little bit of gas reduces the saturation enough to about 96–97% to then substantially increase the resistance to liquefaction. And so in 2019, we set out with this project to treat one site with microbially induced desaturation and to see if we could successfully implement it and desaturate the soils under field conditions. With the field trial in 2019 and the partners that came on board, we were able to expand the scope of this project to 2 field sites and 2 implementations of MID. And we've also been able to continue the work for the last 6–7 years. And so talking about the partners that came on board, we had Portland Bureau of Transportation that gave us access to this site, the Sunderland site. This is one of the field trials that we performed, and they've also given us continued access to the site to this day. So now this is turned into a long-term monitoring project, into a site where we could go out and test different characterization and investigation methods. We've also been able to do workshops, field trips at this site, and look at the soils outside of MID as well. The second site that we were given access to was by Portland General Electric. And this site was at the very top or the north end of the CEI hub. So with this, we were able to show that we could successfully implement MID and desaturate the soils in site conditions and soils that are similar to those beneath the tanks as an important step forward to potentially implementing this method. I'll say that the Department of Oregon Geology, Dogami, Yume Wong at that agency, she was a champion for this project. She came on board and connected us with these folks that gave us access to the sites. And so we really thank Dogami and Yume for that. We had Contech that came out to do site characterization for us. And then following the work, they were there to test and monitor the saturation at the site. They've also worked with us to look at different investigation methods for looking at desaturation, like electrical conductivity or nuclear magnetic resonance. And then Condon Johnson. They were instrumental to getting this work off the ground and being able to go out to 2 sites. They used their ground improvement expertise to mobilize equipment, set up the treatment system for us. They spent countless hours working with us out in the field, getting the equipment out there and setting it up. I truly think we would still be out there just trying to connect hoses if it weren't for them and their expertise. Then this last summer, they also came out and let us borrow additional equipment again. It's been a great relationship. And so thinking back to this work and like the lessons I can take away from this and the partnerships that came on board, one thing I think of is that what I've learned myself is that you can't be afraid to make the ask. We got our ducks in a row, we had the project scope, and I was shocked at how I don't know if we got any no's from anyone, and we were making big asks for this work. And so it was great that there was the setting and the drive and the passion in the area to advance these methods that made folks so eager to say yes to our work, or to our asks. There was also many other contributions that were both big and small. Geo-Syntech provided expertise. They provided a water level meter. The Portland Water Agency, or Bureau of Water, they provided trash pumps. And these all allowed us to continue that work and to expand and take it on. And then finally, going back to the advocacy in the media that really set the stage for us to do this work. Something that I've tried to embrace through this is to try to continue that on, and as uncomfortable as it makes us, to go out and talk about the work that we're doing and the importance of our work. I mean, generally as civil engineers, because this really sets the stage for us to be able to take on these projects and to partner with other folks that want to contribute to similar work as well. And so I think that my last message here is that this type of advocacy matters, and it's something that we should be taking on more so. Yeah, I guess that the last point is that to replace some of those more disastrous headlines of impending doom with more hopeful ones and successes of our projects. So, thank you.